Welcome to today's lesson. I'm Siamasaka Kirandens, and so I'm going to take you through a lesson in physics. In particular, we are going to solve questions on pressure, and so we go straight to the lesson for today. And so the first question goes as follows: a force of 200 newtons was applied on an area of 50 square centimeters. Calculate the pressure by ensuring that you use actually appropriate units. And so we know that the pressure is actually force per unit area, meaning that the pressure is equal to force over the area. And so really, we have been given a few items in the equation, which we already know. For example, we are told that actually the force is 200 newtons. And the area is actually 50 square centimeters. And so we are told actually to calculate the pressure. And so what we need to do here is actually to convert the area into appropriate units, which are actually square meters. And so we are aware that 100 centimeters actually give us 1 meter, and 1 centimeter would give us actually 1 over 100 meters. And 1 centimeter multiplied by 1 centimeter would give us actually 1 over 100 meters multiplied by 1 over 100 meters, which gives us actually 1 square centimeter would be equal to 1 over 100 over actually 10,000 square meters. And so this is how we can convert, and therefore pressure is equal to force over area. And so we know the force here will be told is 200 newtons. 200 newtons over the area. So which is actually, our area will be equal to 50 over 10,000, which gives us actually 0.05, which gives us actually 0.005 square meters. And therefore, this is the one we are going to divide with here, square meters. And so pressure would be equal to actually 40,000. Newtons per square meters. Or we can say actually is 40,000 Pascal. So this is the basic calculation that we have made actually to calculate pressure when we are given the force as well as the area. The next question, calculate the pressure created by a 20 meters depth of water. The density of water is 1,000 kilograms per cubic meters, and the gravitational field strength is taken to be 9.8 newtons per kg. And pressure also can be defined as actually density, if in liquids actually density multiplied by the height multiplied by actually the gravitational field strength. Gravitational field strength. In other words, we are saying pressure is equal to density multiplied by height multiplied by gravitational field strength. And we have been given a few things here. We are aware that from the data that we're given, it's given us 20 meters, 20 meters, and the density is given as 1,000 kilograms per cubic meter. And we are given that the gravitational field strength, is equal to 9.8 newtons per kg. That is on Earth. And so we are told to calculate actual pressure. As we said, pressure is equal to density multiplied by height multiplied by gravitational field strength. And we know all this now. We have 1,000 kilograms per cubic meter multiplied by the height, which is 20 meters, multiplied by gravitational field strength, which is 9.8 newtons per kg. You note that here, this kg, that kg will cancel, and the 1 meter there will cancel with this one. So we're remaining with actually the square meters and the newtons there. And so when you multiply that one, it gives you actually pressure to be equal to 196,000 newtons per square meters. So here we just wanted to show that actually, if we ignored actually atmospheric pressure, probably an object is actually in a depth of 20 meters, and that container where it is actually closed. We can be able to calculate actual pressure using the relationship which is given here, which is pressure is equal to density multiplied by the height and multiplied by the gravitational field strength. We got an equation. Pressure of 300 newtons per square meter is experienced when a force of 3 newtons is applied. Calculate the area over which the force is applied. And so this one we can use actually pressure is equal to force over area based on the data that we are given here, because our data is actually, we are given that pressure is equal to 300 newtons per cubic meter, and the force is equal to 3 newtons. And we are told to actually calculate the area. Area will be equal to, we do not know. And so we can make actually area a subject of the formula. And so we can say area is equal to force over pressure. And we merely substitute. We are given that actually the force is 3 newtons. 3 newtons. And the pressure is actually 300 newtons per square meter. And when we actually calculate, we note that actually our area would be equal to 0 0.01 square meters. So basically, this is how we can calculate this question. Next, we have this question. Two different sized stones are placed in a tin which contains water. What is important here is that actually the tin is closed. That the tin has a cover, meaning that atmospheric pressure is not considered. On top is covered. The surface area of the stone A is 200 square centimeters, and the surface area of stone B is 500 square centimeters. The stones are at a depth of 5 meters at the bottom of the tin. Take the density of water to be 1,000 kilograms per cubic meter and gravitational field strength to be 10 newtons per kg. So this is actually what it is. So we have water inside and we have a lid there. And we have stone A and B. They are at the same depth here. Okay, so these actually they are at the same depth. Okay, and so, actually the depth to which these stones A and B are is 5 meters. And this tin contains water. And so the equations are as follows. Calculate the pressure exerted by water on the stones A and B. And so we are aware that actually pressure in liquids is equal to the density multiplied by the height multiplied by the gravitational field strength. And we are given here that the density, when we look at our data, the density is equal to 1,000 kilograms per cubic meter, and the height is actually 5 meters, and the gravitational field strength is equal to actually 10 newtons per kg. And so we find the pressure for stone A, the smaller stone, which would be actually its density multiplied by the height multiplied by gravitational field strength, which is actually 1,000 kilograms per cubic meter multiplied by 5 meters multiplied by 10 newtons per kg, which actually gives us 50,000 newtons per square meter. That's the pressure for actually stone A. We calculate the pressure for actually stone B, the big stone. It will be equal to the density multiplied by height multiplied by gravitational field strength. And the density, we saw that the density of water is actually 1,000 kilograms per cubic meter multiplied by the height, which is 50 meters multiplied by the gravitational field strength, which is 10 newtons per kg. We note that actually this one will go, and then you have 2 there, that one will go, which gives us actually 50,000 newtons per kg. So we note that actually here the shape and the size does not matter. So what matters is the density, the height, and the gravitational field strength. So pressure is not affected by the shape and the size of the object. So it is only affected by actually the depth. Pressure is only affected by the depth, the density, as well as the gravitational field strength. Okay, so this is very important. We look at the second part of the question. Calculate the force exerted by water on stones A and B. So we are aware that for A, pressure on A, stone A would be actually the force on A divided by the area of actually A. And therefore, the force A would be equal to pressure A multiplied by the area of A, which is equal to pressure. We have found actually 50,000 newtons per square meters multiplied by the area. And you note that the area of actually stone A is actually 200 square meters. So it will be 200 divided by 10,000, which gives actually square meters. And this gives us actually, for A, it will give us actually 1,000 newtons. So that is the force actually exerted on A. It is 1,000 newtons. Then the force on B would be actually pressure on B would be equal to the force exerted by B over the area for B, which is equal to force produced for stone B is equal to pressure on B multiplied by the area on B, which is equal to the same pressure actually 50,000 newtons per square meters multiplied by the area, which is actually 500 over 10,000 square meters. And this gives us actually 2,500 newtons. That is actually the force on stone B. So this, I thought today we can look at these few questions on pressure. If you want to contact me of extra explanation, you can contact me on this number 2+260 977 419949. This is my WhatsApp number. And you can also contact me on the email kesiamasaka@gmail.com. gmail.com. You can actually contact me, and then we can discuss on the lessons or other questions to solve. Okay, I thank you.